So this one is being recorded, and let me go ahead and share my screen. So let me know if you can see that. All right, can everyone see the screen now?
Yes.
Okay, all right, good. Okay, so I will also show you how to use the calculator for this section as well. But this last chapter, which is 7.1, is the most important one because there's a lot of concept on 7.1. After we got a concept, now 7.2 and 0.3, it's just a little bit calculation. So when we do the calculation, we are also trying to explain the concept a little bit as well. So this the whole chapter, for actually not a whole chapter, we only require 3 sections, right? For this chapter is the hypothesis testing with 1 sample. Since this is the 4th level of the statistics, so everything we do is only with 1 sample, not anything with 2 or multiple sample that way. So just let you know, when you do the TI 83 or 84, you're gonna choose the one, always choose the one with 1 sample, okay? And this section here is the hypothesis testing for the being when the sigma is unknown, okay? So anyone still remember what is sigma? Anyone still remember what does sigma represent for? It's the population with standard deviation, okay? So knowing the sigma is very, very important. Actually, in this chapter and the last chapter is kind of a little bit something similar. When the sigma is known, we're using the z-test. In the last chapter, when the sigma is known, we use called z-interval, okay? So this actually have a little bit something similar with the last chapter is the sigma. So in this section, we're gonna learn how to find the p-value and what does the p-value mean, right? And how do you find the p-value for the z-test on the bin, for a bin when the sigma is given? So that is the z-test. Look at that, when the sigma is given, that is a z-test. All right, that's a z-test in here. And how do you use the rejection region for the z-test for being when a sigma is known. Again, z-test when sigma is known. All right. So that is the most important one because the next section we're gonna look at the t-test, and the t-test is sigma will be unknown. All right. Okay. So we're using the p-value to make a decision in the hypothesis. If so, this one we're gonna need to make a conclusion in here. This is the if p is less than or equal to alpha, you reject the non-hypothesis. If p is greater than alpha, now you call reject or fail to you fail to reject the non-hypothesis. Sometimes fail to reject we also call do not reject. Okay, so fail to reject is something also called do not reject the non-hypothesis. All right, in statistics, we usually using this, a little bit of terminology in this for the statistic called fail to reject the non-hypothesis. What does fail to reject? Well, fail to pass the course. What does fail to pass the course? Or you fail to pass the course, that means you do not pass the course, right? So that is the same thing. Fail to reject the non-hypothesis is the same thing as do not reject the non-hypothesis. All right, so we have this table that we can make the decision. If we fail to reject the non-hypothesis, we also need to look at where is the claim. Is the claim in a known or is the claim in the alternative hypothesis? Because this is gonna give you a different conclusion. Okay, and if you reject the non-hypothesis, what does reject the non-hypothesis mean? All right. If you reject a non-hypothesis and your claim is in the alternative, that is the conclusion here. That means you have enough evidence to support a claim. All right, that kind of thing. So we're gonna come back to use this table again and again every time we make the final conclusion. All right. So sometimes people say, well, if I want a one-page note, can I put this one in a one-page note? And certainly you can, you could, because you should, that kind of thing, right? This is the, especially for the beginner, if you are not quite familiar with the conclusion, this will really help, okay? And also this one right here, if P is less than or equal to alpha, you will reject the null hypothesis. That's the conclusion you also need to know, okay? All right, so given these things, now we're gonna look at a little bit decision in here. So if the p-value for a hypothesis test is 0.0237, what your decision if the label of the alpha is 0.05? Okay, so we have a p. I usually like to run up with the p, 0.0237. Okay, so is p greater than or less than alpha? Anyone? We already done up with all the decimal point. So in this case, p is greater than or less than alpha. Well, apparently this p is less than alpha, right? Look at that. I done up with this done up with the decimal point in here. My alpha right here is 5. My p here is only 2. Okay, so in this case, p is less than alpha. All right, this is all, so you can say less than or equal to alpha. So p is less than or equal to alpha. So what's the decision? Decision according to what we have earlier. If you p is less than or equal to alpha, you reject the null hypothesis. All right, so this one p is less than or equal to alpha, so we reject the null hypothesis. So that means the null hypothesis is incorrect, right? You reject them. Why you reject them? It's not a good one. That's why you reject them. Okay. All right. Now let's look at the second one right here. If I choose my alpha label is only 0.01, my p is still 0.0237, right? You run up with all these decimal point in here, integer, decimal point. So apparently right now my p is greater than alpha, right? If my alpha is only 0.01, my p is still 0.0237. Now this time p will be greater than alpha. So p greater than alpha, what do? Do not reject. All right, when p is greater than alpha, do not reject, or you call fail to reject the null hypothesis. Whatever make more sense to you, you can use either sentence. You can use either do not reject or fail to reject the null hypothesis. Okay. All right. So that is in this case, as you can tell, this conclusion you will need to make a note somewhere that you can find it, right? So when p is less than or equal to alpha, you have to reject the null hypothesis. When p is greater than alpha, you do not reject or fail to reject the null hypothesis. So that is the decision, okay? And what is the conclusion? Well, the conclusion you also have to combine with your claim, all right? You claim in order to make the final decision, the conclusion, okay? So how do you find the p-value for the hypothesis test? Well, you really have to write down your known and alternative hypothesis first. Remember, every question, you always need to write down the known and alternative hypothesis. And the one tail or two tail, left tail is one tail, right? This is one tail. Right tail is also one tail, all right? And then this is two tail, all right? So two tail, you have a two area, okay? So if it is left tail, so what does left tail mean? Left tail, that means you have something less than, all right? So this is called a left tail, and it's only one tail, right? And then you also have a right tail. So right tail is greater than or more than. So that is a right tail test, okay? And then if you have something non-equal to, all right, mu is non-equal to something, to k. Now you have a two-tail. That means you have a half on the left, half on the right. So each one will be half of the p-value, okay? So that is what you call left tail, right tail, and two-tail. When you write down the known hypothesis, remember, known always have an equal sign, right? If equal to, less than or equal to, or greater than or equal to, always have to have an equal sign, right? And then you pair with the alternative one. If this one has an equal, your alternative one will be non-equal to, and that will be the two tail. So when you look at the one tail or two tail, you always look at the alternative one, okay? And then if you have a less than or equal to, your complementary will be greater than. Or greater than, this is a right tail test, okay? Right tail, this one, right tail, greater than, okay? If your known hypothesis has greater than or equal to, your complementary will be less than. All right, and less than is a left tail test. So this is a left tail test in here. Okay, so when you look at the left tail or right tail, you always have to look at the alternative one. Okay, you always need to look at the alternative one in here. All right, so now let's look at one of these questions in here. So how do you find the p-value for the left tail test? That the z-score is negative 2.23. All right, so the p-value is the area for the bell curve. Okay, so since you have a left tail test, so you go to read the z-score table. This area, the area. All right. Okay, this area is the p-value. Okay, the area is the p-value. And where do you look at the z-score? Well, remember you have a z-score table, right? We have this z-score table. You can go to look at the table. All right. This one you can read the table forward, so it's very easy to do it. Negative 2.33. So this is your table 4, right? The standard normal distribution. Negative 2.3 right here, and then 33. So that is 0.0099 if you have a negative 2.33. Negative 2.23. Okay, so it's negative 2.23. Negative 2.23. So that's all right. Let me go ahead and delete this one. Okay, all right. I'll monkey with that later. All right, so 2.23. So that's this one is 2.23. That's negative 2.2 in here. Okay, let's see. Okay, negative 2.2 right here, and then 2.3 right here. Okay, so that is actually this one is so this one is 0.0129. Okay, so that is how you get this answer, 0.0129. Okay, so when you go to read the table, and that is your p-value. Okay, and then your p-value here is negative 0. I'm sorry, p is always positive. Okay, your p-value is 0.0129 compared to alpha, right? So how much is my alpha? My alpha is 0.01. Okay, so is p greater than or less than alpha? Is this p greater than or less than alpha? We're going to be able to compare, right? So since the alpha stopped in 0.01, my p is greater than alpha in here, right? Because this is 0, 0. All right, so my p is greater than alpha. So p greater than alpha, that means do not reject. or call fail to reject the known hypothesis, okay? The conclusion we have earlier is P had to be less than or equal to alpha. Now you reject. When P is greater than alpha, you do not reject or fail to reject the known hypothesis. Okay, so that is how you can make this kind of decision in here. All right, if you have a p-value, this one is a two-tail test, and then the z-score is 2.14. All right, so decide whether you reject or do not reject the known hypothesis when the alpha is 0.05. Remember, this telling you is a two-tail test, so each tail is just half of the p. Each tail is half of the p. All right, so when you go to read the z-score, 2.14, this is the area all the way to the left. Okay, it'll be area all the way to the left in here. So how do you find this one? Well, same thing. You go to read the table. All right, so your z-score is 2.14. Positive 2.14. Okay, so we have a 2.1 in here, 2.1 in here, 2.14. Okay, right here. All right, so that's 0.9838. So 0.9838. All right, so 9838. All right, so if you read a table, it's always the area to the left. All right, so my area to the left here is 0.9838. And how much is my area to the right? So this area to the right includes this tail, okay? But if I want to just find this right tail in here, this tiny tail, how much is my tiny tail, which is 1/2 of the p, right? This tiny tail of the area will be 1 minus area to the left, okay? 1 minus area to the left. And then you go to subtract from 1, so that will be 2610. All right, so that is 0.0162. And 0.0162, that's just half of this area. So how much is my p? Well, this is my half of the p, right? So my p, I have to multiply both sides. I have to multiply 2. So it's 2 times 0.162, which is 0.0324. Okay, so my p-value for this two tail is 0.0324, and my alpha here is 0.05. So you can tell at this time my p is less than alpha. Look at that. This digit p is only 3. Alpha is already 5. So p is less than alpha, right? So less than alpha, that means you reject the known hypothesis. Okay, when p is less than alpha, you reject the known hypothesis. All right, so that is giving you step by step. How do you find this one? How do you find the p-value when g is given? Sometimes when g is not given, you will need to find the g on your own, the z-score on your own. Okay, the z-test, that is a z-test formula. X bar minus mu over sigma divided by square root of n when n is greater than 1, right? You know, we need to use this one in here. All right. So how do you do the entire? So this is kind of like the entire question. If I give you the entire question, how do you do the whole thing? Well, step 1, we need to identify is this normally distributed or not. Okay. Usually the question we are telling you, this sample or this data is normally or approximately normally distributed. If you didn't tell you if you're gonna look at the n, if n is greater than or equal to 30, we can also say this is approximately normal distribute because the sample size is large enough. Okay, so that is the first thing. The second thing right here, also the most important one, you will need to identify the known and alternative hypothesis, which is the one we just talked about earlier, or we also had that in section 7.1, right? So that's step 2. You have to write down the known and alternative hypothesis, and then you need to look at the alpha value. Most of the time, the question we are giving you the alpha value. So you can go to calculate the p-value and then compare with alpha. Okay, and then this one, you're gonna go to use the formula to find the z-score. After you find the z-score, you can find the area, right? Depends on this is left tail, right tail, or two tail. So you can find the p-value from the table 4. Okay, so that is this one. And then depends on your left tail or right tail or two tail, you're gonna be able to, you know, identify the correct p-value, right? If this is two tail, remember you have to multiply by 2 in order to get a whole p-value. All right. So if p is less than or equal to alpha, you will reject the null hypothesis. Otherwise, you fail or do not reject the null hypothesis. Otherwise, that means if p is greater than alpha, right? You will fail to reject or do not reject the null hypothesis. And then we have to interpret the decision of in the context of original claim. All right. So let's look at one of the detailed question, and then we're gonna use this question to explain every procedure we just talked earlier. The good news is the next section are very, very similar to this section, okay? Instead of using Z, you're just using T. Otherwise, the procedure will be very much the same, all right? So let's look at this one right here. Hypothesis testing using p-value, okay? In an auto racing, a pit stop is where a racing vehicle stops for new tires, fuels, repairs, and other mechanical adjustments. The efficiency of the pit crew that makes this adjustment can affect the outcome of a race. A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 30 seconds. All right, so someone telling you, say, this one is less than 30 seconds. Do you believe them? Well, now a random sample of the 32 pit stop times has a sample mean of the 12.9 seconds. Assume the population standard deviation is 0.19 seconds. Is there enough evidence to support a claim a alpha equal to 0.01 label? All right. So how do you answer this type of statistic? Sometimes in the past, when I ask people to do a project, this whole question can be a project, right? That kind of thing. You go to correct the 32 pick stop time, and then you got a project already. All right. So since this one telling you okay, this one telling you the sample size n here is 32, right? 32 is really big enough. All right, it's greater than or equal to 30. So you can treat this whole thing, even it didn't telling you the data is normally distributed. You can assume this one is approximately normal distribute because the sample size is large enough. So that means we can use the bell curve to do this whole thing. All right, we can use the bell curve in here. All right, so let's see what is the bin. The bin mu here is what? The bin here is 12.9 seconds, and here is 32. This telling you the population standard deviation. So mu is 0.19. Since this one telling you the population standard deviation mu, so we're gonna use the z-test, okay? Because mu, I'm sorry, sorry about it. That's not a mu, that's a sigma. All right, that's a sigma. Okay, mu is the bin. Sigma is 0.19. Sigma is 0.19. So that is the population standard deviation. All right, this one sigma is known. Sigma is known. Or sometimes we say sigma is a given. It's a given. All right. So we're gonna use the z-test in here. That's z-test. And we're gonna need to write down the known and alternative hypothesis. Okay. So we're gonna write down the known and alternative hypothesis. That is our next step. Okay, so where's the lone hypothesis in here? Well, this one telling you a pit crew crime that is being stop time is less than 13 seconds. So less than, it didn't include the equal sign. So mu is less than 13 seconds. Well, less than should go into the alternative one because it didn't include the equal sign. Okay, and what is my complementary for less than? Will be greater than or equal to. Okay, so that will be my non-hypothesis. Non-hypothesis always include the equal sign. Okay, all right, since this one is from the question telling me this is a statement. The statement is also called a claim. All right, or sometimes it's called a statement. The claim here is the statement. All right, the statement in here. Okay, so this statement or this claim is in the alternative one. We're gonna have to use this criteria to make the final conclusion at the very end. All right. We also know this is a depth test, right? Because the alternative is less than, so it's a depth test. And we also know that this is a G-test. So we're gonna need to go to find a G-score. Okay, finding the G-score in here. My X bar so I need to make a little bit of I need to make a little bit correction here. Okay, so this being here 13 seconds is the population mean. Okay, this 13 seconds is the population. The sample being is the X bar. X bar here is 12.9, which is less than 13. All right, so that's 12.9. That is your X bar. Okay, so X bar X bar here is 12.9. Okay. The crew claimed that the bean stop time is less than 13 seconds. So 13 seconds is the population mean in here. Okay, so that is very important because this one is telling you the sample bin. All right. So you go to choose a random sample of 32 of them, and they have a sample bin is 12.9 seconds. All right. And the sigma here is 0.19 divided by square root of n. N here is 32. All right, so I'm going to calculate my G-score. Remember, if you put everything in a calculator, make sure you use the parentheses. If you don't use the parentheses, you're gonna give the incorrect answer. Okay. All right, so let's go ahead give it a quick calculation. We're gonna have a parenthesis. The denominator, you also need a parenthesis because you got two items. And then this is second x squared, that's the square root of 32. All right, and make sure you close the parenthesis. Okay, so if I run to 2 decimal point, which we usually run to 2 decimal point because that's the number we can read from the table. So this will be negative 2.98. Negative 2.98. All right, so since we have a depth test, okay, less than is depth test. So depth test is my G-score. Okay, so this is my G-score. Okay, now we have a G-score here. G-score is negative 2.98. And whatever I do the area, this area will be the p-value. Okay, this area is a p-value in here. So number 3, we're gonna go to find our p-value. Okay. So we're gonna if we right tail, you're gonna have to subtract from 1, but this is 1 tail. So whatever you read from the table is the p-value. Okay, so negative 2.98. You're gonna go to negative 2.9 in here. Okay, negative 2.98, which is right here. Okay, so 0.0014. Okay, so that is our p-value, okay? And then we already have alpha here, so we're gonna compare p and alpha. All right, so alpha here is 0.01. Okay, so my p second digit is still 0. My alpha second digit is already 1. So apparently p is less than alpha. Okay, p is less than alpha in here. So when p is less than alpha, what is the decision? Reject or do not reject the null hypothesis? This will be the reject null hypothesis. When p is less than alpha, reject the null hypothesis. Okay, since we reject this null, so that means this null is incorrect, right? This one is incorrect. You reject the null hypothesis. Why you want to reject them? Because it's incorrect. So that means this one is correct. Alternative one will be correct. Okay, so that means the alternative one is correct. And what's the alternative one? Alternative one said the stop time, the bin stop time is less than 13 seconds. So that one is correct. All right. So if you go to look at the tables, we're gonna just say there's enough. So there's enough evidence to support a claim. So our conclusion here is we have enough evidence to support a claim. All right. So what is the claim? The stop time, okay, stop time is less than 13 seconds. All right. So we have enough evidence to support this claim. All right. So let's go back to look at this table. If you do not know how to make a conclusion, all right. Let's look at this table again. Look at it. We have decision is we reject the null hypothesis, right? We have a p is less than alpha, so we reject the null hypothesis. Our claim here is in a alternative one, so that's we make this conclusion. All right, so we make this conclusion. There's enough evidence to support a claim. Okay, so when you come back here, let me just go ahead copy this one, the whole thing. Okay, so when we do this one right here, we have enough evidence to support this claim. All right, we have enough evidence to support a claim in here. Okay, so just paste it. Ooh. It didn't paste. All right, so that is this one right here. I just showing you how to do this one step by step manually. Okay, the good news is you can also do this whole thing in a calculator. All right. So how do I do this whole thing in a calculator? Let me show you this one. You will be really, really surprised how easy to do the whole thing in a calculator. All right. But sometimes the question might not ask you the whole thing. It might just ask you 1 or 2 steps in the middle, right? But you still need to know how to find it. All right. But if this one, let's see how do we do this whole thing in a calculator. You go to the step. We're gonna go to the test. Look at it. This time we're gonna use the hypothesis test. So we already identified we're gonna use the z-test, right? So the first one highlight is the z-test. We hit enter. We already know the sample bin, so we're gonna go to using the state. So hit enter again, and then we input the mean here was 13, I think. Let me go back to take a look. Okay, mu here is 13, sigma here is 0.19, x bar here is 12.9, and n here is 32. Okay, and then we have to give this one say what kind of test we have. Well, we know from the hypothesis, alternative hypothesis, we know this is a left tail test. So left tail is less than, okay? And then we're gonna just go ahead here, calculate. Look at this one right here. When you calculate this one, it's giving you the G value, right, or the G score. And the bonus here, it's also giving you the P value right here. Look at it. So we have a negative 2.98 when you run to 2 decimal point. We have exactly the same. All right, look at it. We have exactly the same G score, okay, negative 2.98. If we run to 2 decimal point, we also have a same P value, right? So our P value here is probably sometimes a little bit off, but will be enough to let you identify. We have a 0.0014, so 0.0014, right? The calculator actually a little bit more accurate because it retains more decimal point. All right, but as you can see, this is enough, to compare to, to the alpha level. Our alpha is 0.01, right? So apparently this is much less than the alpha. Okay, so that is this one right here. You can use the calculator. The benefit of using, or the good news of using this one is you already find the G score pop out automatically and also giving you the P value. Okay, after that you still need to come back to be able to answer this question. Right now you compare P and alpha, and then you reject the known hypothesis. After you reject the known hypothesis, you have to be able to make a conclusion, right? Say we have enough evidence to support a claim that the start time it is less than 13 seconds. All right. So this, we are giving you the whole picture to combine everything together. All right, let's look at another question in here. Okay, hypothesis testing. According to a study of U.S. home that use heating equipment, the mean indoor temperature at night during the winter is 68.3 degrees Fahrenheit. You think this information is incorrect? Well, you don't know. You have to prove them is correct or not, right? So you randomly select 25 U.S. homes that use heating equipment in the winter and find out the mean indoor temperature at night actually is 67.2 degrees Fahrenheit. Okay, from the past study, you know the population standard deviation, which is sigma, is to be 3.5 degrees Fahrenheit. And this telling you the population is normally distributed. So is this enough evidence to support a claim at alpha equal to 0.05 level? Okay, and then using the p-value. All right, so we still need to, this already telling is normal distribute, so we don't have to think twice for that one, okay? So we're gonna go ahead, write down the known and alternative hypothesis because we need to know we have enough evidence to support or not. Every question, when we need to make a conclusion, we need a known and alternative hypothesis, okay? All right, so what is a known and alternative hypothesis? Let's see what the question giving to us. And this one telling you the population standard deviation. All right, so that's a sigma. Sigma is 3.5. So sigma is known. Sigma is known. Okay, so we're gonna use the G test. All right, very important. They're giving you the population standard deviation. So sigma is known, is a G test. All right. This telling you the mean indoor temperature is 68.3 degrees. So mu is 68.3 degrees Fahrenheit. This one is the equal sign. So it should go to the known hypothesis because it includes the equal sign. This is also our claim or our statement from the question, right? The question, claim that this is the statement. The statement from the question say it's 68.3 degrees Fahrenheit. So that is in the known hypothesis. And let's go ahead write down what is my alternative one. Well, since I have an equal sign, alternative one will be non-equal to. Okay, so this will be a two-tailed test. Look at it, it's a two-tailed test because you have a non-equal to. So you have a left and right. Okay, so two-tailed test, two-tailed test. All right, so if I use a calculator, it will be really easy because the calculator automatically giving me my whole p-value, okay? And then also giving you the z-score and also giving you the p-value. All right, and then I just need to go to compare my p-value with my alpha to see p is greater than or less than alpha, and I already make a conclusion. All right, so we're gonna go ahead and use the calculator for this whole thing, and you will be surprised how easy is this one. Okay, so again, we know we go to state, go to test, and we already decide that one is a z-test. Same thing, you go to state. If you have a list of the data, you can input into L1 and using data, right? But this one, since we already know the bin, so we're gonna using the state in here, okay? So the mu here is 68.3, 68.3, okay? Sigma here, change your sigma is 3.5. Your X bar here is you go to find 25 sample, right? And the sample temperature here is 67.2. Okay, and then your N here is 25. This time we have a two-tailed test, so you want to make sure you two non-equal is a highlight. Okay, non-equal is a highlight, so that's two-tailed test. And then you go ahead and hit calculate. All right, so look at this one, very effective. You have a z-score, you have a p-value. This p-value is already include two tails, so you don't really have to go to multiply two on your own. So it's really convenient. So if I run to 2 decimal point, my z-score will be negative 1.57. The good news is, so that's the second one, you calculate the z-score. The third one, you calculate p-value. All right. I already got a p-value from the calculator. My p-value here, if I run to 3 decimal point, right, will be 0.116. 0.116. All right. Number 4, we're gonna go to compare the p with alpha. My alpha here is 0.05. Okay, so look at this one right here. You fourth digit, p is already 1. This alpha fourth digit decimal point is still 0. So apparently p is greater than alpha. Okay, p is greater than alpha. So when p is greater than alpha, it's called fail to reject or do not reject the non-hypothesis. Okay, so do not reject this non-hypothesis. And now we're gonna have to go to look at how do we make a conclusion, right? So remember, we failed to reject a non-hypothesis, and our claim is our claim is in the known. Okay, so let's go back to look at this page. Maybe I can copy this page to somewhere closer. All right, let's copy this page to here. Don't have to go back. Okay, so I failed to reject the non-hypothesis. All right, so we're gonna look at this one right here. We failed to reject the non-hypothesis, right? We failed to reject the non-hypothesis this time, so we're gonna look at this one. Okay, and where's our claim? Our claim here is in a non-hypothesis. Okay, our claim here is in a non-hypothesis. So this is your non-hypothesis. Claim is in a non. All right, so that is my conclusion. So my final spot should be this one right here. This is my final conclusion because I have a claim. Oh, I'm sorry. Claim is in a non. All right, let's see. Let's just make sure. Our claim is in a non, not in the alternative one. Okay, so very easy to make mistake. All right, our claim here is in a non-hypothesis. So our claim here is in a non-hypothesis is in here, right? And we fail to reject. So this is our conclusion. Look at it. This is our conclusion. There's not enough evidence to reject a claim. All right. So that is your conclusion in here. So we don't have enough evidence. We fail to reject. fail to reject the null hypothesis. That means this null hypothesis may be still right. Okay, so that means you don't have enough evidence to reject this one. You cannot say this one is equal to fail to reject the null. All right, so that is this one. There's not enough evidence to reject the claim. Okay, the claim is in the null. All right, so you don't have enough evidence to reject this one, so that means this one might be still correct. All right, so that is how you do this type of hypothesis testing in here. I know sometimes when you use the terminology in statistics, seems a little bit hard to understand, right? Okay, so we fail to reject the null hypothesis. So that means there's not enough evidence at a 5% level of the significance to support a claim that the mean indoor temperature is 68.3 degrees. Okay, so that is how you do this one. So this table is very important. If you do not, especially if you do not know how to make the final conclusion, right? And this table will definitely help. Okay. So you're gonna have to go to look at your claim is in a known or your claim is in an alternative, right? And then trying to see if you reject or you do not reject the known hypothesis, and then choose one of these 4 outcomes. All right. So that is our section through 7.2, which is G test. Okay, G test in here. All right, let's see. Did anyone has any questions? Anyone has any questions about this one? Q&A on the chat. Okay, I don't see any question here. All right, you can always jump in if you have any questions. Okay, we're gonna go ahead and finish the last section for this chapter. So only one more section left. All right, let me go ahead and copy it. Yeah, oh, I did have a copy here, okay. For section 7.3, even we have a t-test for this one, but we're gonna still using this same table, all right? So the good news is the process for hypothesis test is all the same. Okay, we're gonna still be able to find the p-value compared with alpha. We still have to identify the known and alternative hypothesis, okay? So the only difference here is we're gonna using a different test, all right? When sigma is unknown, okay? When sigma is unknown, this is called t-test, okay? Just like we have a t-interval earlier, this one we call the t-test, or sometimes called a student test because it was done by a grad student, okay? All right, so find a critical value for the t-distribution using the t-test for the sigma is unknown, okay? Sigma is not known, that means it's unknown. And then we can use the calculator to find the p-value and then compare with the alpha. That would be the easiest way, okay? All right, remember the t-test, we're using the degree of the freedom, okay? So using the degree of the freedom, which is df is n-1, right? In here. And then we still have a left tail, right tail is all called one tail, right? And then you have a non-equal to, it's called a two-tail test, okay? So the critical value, the t-value, this is a left tail, all right? This is a right tail, and then this is a two-tail test in this kind. So it's very, very similar to the previous section we had, all right? We're gonna still need to be able to find a critical value for the t. On the left test, alpha is 0.05, n is 21. Remember, if you want to find a critical value for the t, you have to use df, and df is n-1. Okay, so 21 minus 1 is 20. So degree of the freedom is 20, and then you go to look at alpha is 0.05. So let's go ahead, open a table. This one, you're gonna read a different table, okay? not a Z table, but T table. All right, so now you look at the T distribution, that's T table in here. All right, T table, okay? And the degree of the freedom is 20, so we have a 20 right here, right? And then we also look at the alpha is 0. All right, so alpha is 0.05 and it's one tail, I think. All right, yeah, alpha is 0.05. Okay, so 0.05 is one tail. You got to look at the one tail in here. And then the 20 is the DF. Okay, this is DF, it's not an N, degree of the freedom. So you look at this one right here. So your critical value should be 1.725. Okay, 1.725 in here. All right, so that is, look at this one. And one thing, okay, very, very important here is the T value from the table 5 is always giving you the area to the right. If you have an area to the left, you're going to have a negative T value. If you have a two-tail test, one T will be positive, one T will be negative. Unlike the Z table, we're giving you the negative Z score. The T table always giving you the positive value. So if you know you have a left tail test like the one we have here is called the left tail test. So you have to add a negative on your own, okay? Because if you go to read the T table, it's only all positive. Okay, you look at alpha is 0.05. Okay, alpha is 0.05 right here, right? And then the degree of the freedom is 20, so that is 1.725. But if you have a left tail test, you must add a negative on your own. Okay, so this one is especially important because if it's a multiple choice, sometimes you might get a wrong answer, okay? Because it's a left tail test, so you have to add a negative on your own in here. All right, this one is right tail test. So right tail test, T will be the positive one. So N is 17, alpha is 0.01, right? So you go to look at your DF is N minus 1, so that N minus 1 is 16. All right, so you're gonna go to look at 16, DF is 16, and then the alpha is 0.01. So 0.01 is right here, one tail, right? And then 16, so that is right here, 2.583. Okay, 2.583. And this one is positive because it's a right tail test. All right, if you use a two-tail test, now you will need to, one is negative, one is positive. Well, you don't have to write down positive, okay? But N is 26, so my DF here will be N minus 1, so that's 25, right? And then you use alpha is 0.1 for the two-tail. So go to same thing. Let's go to look at the table. This is 25, all right? Right, this is 25. So we're gonna look at all these low, all right? And then it's two tails. So make sure you choose the two tail because this one, it does telling you the two tail. Two tail test, the alpha is 0.10, okay? So two tail, alpha is 0.10. So right here, okay, this one right here. And then we're gonna look at this one. So this one will be 1.708. All right, and then you have to write down one is positive, one is negative, because you have a two-tail test. All right, so 1.708. One is positive on the right, on the left will be negative. All right, t-test and z-test is very similar. This is a t-value, okay, using x bar minus mu over x divided by square root of n. If you have a z-score, this one is a sigma, right? Z-score is similar. X bar minus mu over sigma divided by square root of n. So you're using sigma for the z, using x for the t, or for the sample, okay? So that is the only difference. Otherwise, calculation is very, very similar. You still have to write down the known and alternative hypothesis. You still have to identify the alpha, and then you go to look at your t-value, okay? And if you look at the t-value, you can use the calculator to find the p-value, or you can use the called a critical region, all right, to compare. And then you also have to make a decision trying to see if you reject or do not reject the known hypothesis, okay? Let's look at one of the questions and then trying to see, are you going to use a G or T test? That's probably the most important one here. So a used car dealer said the mean price of a used car sold in the last 12 months is at least 21,000. So what does at least mean? All right, it's so important. All right, you suspect this crime is incorrect and find that a random sample of the 14 used car in the last 12 months has a mean price of this much with a standard deviation this much. Is this enough evidence to reject the dealer's crime at alpha equal to 0.05 level? Okay, so very important, G or T test and why? G test or T test and why? Okay, because on the test it didn't tell you. You say, hey, this one is from section 7.2, and this one is from section 7.3, right? You won't telling you. Okay, so in order to identify G or T test, we're gonna have to go to look at the sigma. Is sigma known or unknown? If sigma is known, we will have a G test. If sigma is unknown, we're gonna have a T test. Okay, so let's go to look at this sample standard deviation. This standard deviation. Standard deviation is 2950. Is this sample or population standard deviation? Well, this is a random sample of 14. Look at that. They said this is your random sample of the 14 used car sold in the last 12 months has this price and this standard deviation. So apparently this standard deviation is the sample, not a sigma. Not a sigma. Sigma is unknown, so therefore we use the T test. Okay, we use the T test in here. All right, so now we're gonna go to write down the known and alternative hypothesis, because this is important because we have to use that one to make the final decision, right? Okay, so what does ADs mean? Used car dealer said the mean price for the used car sold in the last 12 months at least, that means greater than or equal to. Greater than or equal to. Since this one has an equal sign, so you're gonna go to the known. Mu is greater than or equal to. All right. This is also the claim or the statement from the question. Okay. Now my alternative for this one will be just less than. All right. So that means this is a left tail test. Okay, left tail test in here. All right, so I can either go to find my t-value, or I can put this whole thing into the calculator. Using the calculator to find the t will be the really quick and easy one. And the good thing is the calculator also help you to find the p-value. Okay, so we're gonna go to the test, but this time we're gonna using the t test, not the z test. All right, using the t test, and then this is similar. My mean here interface is similar, but the outcome will be different than the z test. All right, 21,000. I think the X bar here is 19189. Okay, my sample standard deviation here is 2950. Okay, and then n here is 14, right? N here is 14. And we said earlier, this is a left tail test, less than. So we make sure we choose the right test, left tail test. All right. And then we just go ahead, hit calculate. So look at this one right here, your t-value, if I ask you the t-value, we run to 3 decimal point usually for the t. So t-value is negative 2.297. All right, my p-value, the most important one, my p-value here is 0.019, right? If we run to 3 decimal point, 0.019. All right, so we're gonna compare the alpha. My alpha here is 0.05. So what do you think? P is what? P is less than alpha. P is less than alpha here. Look at it. So P is less than alpha. We're gonna reject the non-hypothesis. All right, so if you still don't remember how do you reject a non-hypothesis, what kind of conclusion you have? All right, so you reject a non-hypothesis and you claim is in the known, right? You reject a non-hypothesis. So what kind of conclusion you make in here? All right, so look at this one right here. You claim is in the known, okay? And then we reject a known, so that means we have enough evidence to reject this claim. We have enough evidence to reject a claim. Trying to go back to the question. All right, so we have enough evidence to reject this claim. All right, you reject the claim in here, okay? Is there enough evidence to reject the theta claim at alpha equal to 0.05 label? The answer is yes, okay? We do have enough evidence to reject this claim in here. All right, so that is this one, okay? This is just a little bit of explanation. If you do that by hand, you will need to go to calculate your t-value, okay? T-value in here. All right, so if we have a t-value, okay, so let's look at this one, right? We have t is negative 2.297, all right? Negative 2.297. If you compare the critical region, okay, so if you don't go to find a p-value, just using the critical region. So this is my my test, my t test score, right? And then if you use alpha equal no alpha, if you have a go to find a degree of the freedom, okay, degree of freedom is n minus 1, so I have a 14 minus 1 will be 13, right? And alpha equal to 0.05. So if you go to read a critical value, okay, if you read a critical value here, df is degree of the freedom is 13, right? So 13 right here, 13 right here, okay? And then the alpha is one tail is 0.05. So that is, you have this one, 1.771 for the critical value, okay? 1.771, but it's left tail, so you put a negative in here. All right, so if you using the call compare the two t-value, call the critical value, okay? This is the second method to see if you reject or do not reject the non-hypothesis. All right, since my t here is inside, this is called a rejection region. This is called a rejection region. All right, since my t here is inside the rejection region, Okay, my t is less than the critical value. So my calculation, my t is negative 2.297, right? And then the reject value here is negative 1.771. So that means this region is called a rejection region. And since my t is inside the rejection region, so the conclusion here will be reject the null hypothesis. All right. So that's another way to see if you want to reject or do not reject the null hypothesis. If my t is outside the rejection region, now you do not reject the null hypothesis. All right. So that's the second way. The quick and easy way is compare p and alpha. Okay. If p is less than or equal to alpha, you reject the null hypothesis. So that's the quick and easy way we have been talking so far, right? And then another way to identify reject or do not reject, you can compare the two z-score or compare the two t value. Okay, you're using the alpha and the degree of the freedom to find the critical value and then find the rejection region. And then if your t value is inside the rejection region, that means you reject the null hypothesis. Okay, so that is another way to do this one. All right, so basically that is pretty much it for this section in here. All right, using p-value with this one right here. So when you use the G or T test, that is the key thing. Okay, let me go ahead and giving you a little bit of conclusion in here. Z or T test. Okay. In our chapter 6 is G interval. All right. In our chapter 7 here is G test. Okay, so when you use the G, the reason you use G is when sigma is known. All right. Or sometimes it says sigma is given. All right. So you have to know what is sigma. Sigma is called a population standard deviation. All right, so sometimes it will telling you in the description, say population standard deviation. Sometimes for some simple question, they don't describe the population standard deviation. Sometimes the question just giving you sigma, okay? So when you see the sigma, or when you see the population standard deviation, that is belong to G, okay? In chapter 6, you're gonna use the G interval. In chapter 7, you're using the G test. All right. And if sigma is unknown, you're gonna use the T interval for chapter 6. Okay. For chapter 7, you're using the T test. All right. T test. So this one is sigma. Sigma is unknown. All right. The only thing given to you is a sample. Okay, sample standard deviation. They're still giving you X. X is given. X is given. Or X is known. Okay. They're giving you this one. This one is given. All right. This one is the X, the little X. Little X is given, right? So that is a sample, okay? So when you see the sample standard deviation, not a sample mean, but sample standard deviation, okay? Has to be a standard deviation, okay? If they're giving you the sample standard deviation, now you're using the T interval for chapter 6, using the T test for chapter 7, all right? And the good news is G or T interval, G or T test, you can all use the calculator, right? You can all use the calculator to find. Remember, if you want to find the interval for chapter 6, you go to the test, and then you go down here. All right, you go down here for the G interval, okay? And then you go down number 8 for the T interval, okay? And then today we talk these two hypothesis test. So you have a G test and you have a T test in here. All right. So if you forgot a G or T interval, you can go back to my last video for the chapter 6. All right. But the Z and T test is the one we just had today in here. Okay. So that is pretty much it for the chapter 7 in here, which we require 3 sections. Okay. All right. Any questions? This will be our last online class. All right. We don't have a class next Saturday because next Friday because actually the final should be due by next Friday, but we're giving you until Saturday, the the last day, to do that. Okay. So make sure you finish everything by Saturday, the latest one. All right. If you wait until Saturday, don't wait until Saturday night because something, sometimes your internet may not work or something like that. So always put a little bit budget on there. Okay. So let me know if you have any questions. And I am going to stop the recording.